Okay, we're going to look at Chapter 2, Section 1, and we're going to prove that if A is an n by n invertible lower triangular matrix, then A inverse is lower triangular. And we're going to focus on, first off, a definition of A inverse. So A inverse is 1 over the determinant of A times the adjoint of A. And so we're going to use these definitions to kind of help us figure out what's going on. And also keeping in mind that theorem 2.1.3, I think, again, yeah, 2.1.3. So some things we know. So theorem 2.1.3, if A is triangular, upper, lower, or diagonal, any form of triangular, then the determinant of A is equal to the product of the diagonals. So for our purposes then, this is going to be a number. Because it's invertible, none of these are 0. Right? If we're stringing all of our equivalencies together, the determinant has to have a value. If one of these were 0, then in this it would be not invertible. And so what we want, so I'm just going to call this, big D for, not big D because that'll confuse with diagonal later. I'll just, it's a number, so we'll make it a kappa. Right? It's some number. So everything that's going to determine the form of this matrix is the adjoint of A, because the triangular matrix times K. So let's make A as generically as possible as we can. So we have A11, 0, 0, 0, all the way out to A1n, A21, A22, 0, 0, all the way out to 2n, A31, A33, whoops, A32, A33, 0, all the way out to, and then we'll have A sub nn here, and we'll recognize that everything in here are zeros. And then let's see, A41, A42, A43, A44, and then we'll connect our diagonal, and all of these can have values. So there's our generic lower triangular matrices. And so we have to show that the adjoint of A is lower triangular. And so A, or the adjoint of any matrix, is defined. So the adjoint is equal to the cofactor matrix transposed. And the cofactor matrix is going to consist of all of the cofactors of matrix A. And we define the element Cij to be -1 I plus j times the determinant of the minor. So that means each of these are going to be a number, and some interesting things happen. So I'm going to want to fill out this C matrix. we want the C matrix of all the cofactors. So we're going to look at some cofactor construction. So I'm going to construct a C n by n over here, and we're going to work on the elements of C. I'm going to start with A11. And if I look at the cofactor of that, so the minor, so C11 is going to be -1 times 2 times the minor. Well, I'm going to lose my first row and my first column. It's going to have A22 and then in zeros after it. A33 and zeros after it, all the way down to n, n, n. And there'll be values in here. And so this again is lower triangular, and it's going to give me a determinant that's the product. In fact, C11 is going to be the product of all of the diagonal elements that are not A11. C22 converse likely is going to be A11 times A33, and then the product of everything down to A and N. So we're going to get the product of everything but A22, and so on as we work down. Because any one of these cofactors, if I cut out their row or column, so if I look at A33 here, cut out this row of column, I'll look at A33 specifically. So C33 is going to be -1 to the 6th times. All right, so I'm going to cut out the third row and the third column. So I'm going to have A11 and then all zeros over to here. I'm going to have A21, A22, and then in all zeros to here. Now I'm not going to have the third row or the third column. So I'm going to have A41, A42, and then an A44 because the third column's missing. And so I end up collecting all of the diagonal elements except A33. So we're going to know that we're going to have values. None of these are 0 down our diagonals. So the cofactor expands with values down the diagonals. Let's see if I can get A in here. All right, so we'll go back up to the A matrix. So what we're going to need to do is we're going to need to look at what happens. I'm going to actually work my way down A21. And we'll look at the cofactor expansion of A21. So A21 is going to be -1 cubed, so it's going to be a negative. And then I'm not going to have the second row or the first column. So I don't have the first column, and I don't have the second row. So my first element is going to be a 0, where the A is. Right? Because if we come back here and our cofactor, we're going to block out the first column and the second row. And so my first element's going to be a 0. And then zeros all the way over. I'm not going to have the second row, so I'm going to have A31, A3. I'm also not going to have the first column. So I'm going to actually have A32, A33, and then it's zeros all the way over. I'm going to have A4, 2, A4, 3, A4, 4, and then zeros all the way over, and so on. Because when we block out those, well, this is a lower triangular matrix because this is all comprised of zeros. But it has a 0 here, so this determinant comes to 0. So A21 is going to be 0. And I'm going to look at A31 then. So that's going to be -1 to the 4th. And so I'm looking at A3, 1. So I'm not going to have anything in the first column. So my first element here is A1, 2, which is 0. And then I'm going to have A2, 2, which is followed by zeros. And I'm going to have A4, 2, A4, 3, A4, 4, followed by zeros. And so in this construction method, I've got zeros up above, and I have zeros down below. So again, this is still going to be lower triangular, and this is going to be 0. And I think we can see as I scroll my way down C11, these zeros are going to zipper down the diagonal here. If I did A4, 1, it would be negative 1 to the 5th. I would start with A1, 2, which is a 0. Then I'd have A2, 2, A2, 3, and then I'd have A3, 3, or 3, 2, A3, 3, all zeros from A over. And so this zippers down. So coming down this first column is all zeros. And so let's look at our next column here. So we'll look at C 3, 2, or so C3, 2. So it's negative 1 to the 5th. And so I'm going to have my first row, my first column. So I am going to have A1, 1, and then everything's going to be followed by zeros. And then I'm going to have A2, 1, A2, 2, and then everything followed by zeros. But I'm not going to have A3, so I'm going to have A4, 1, A4. Oops, I'm not going to have 2's either. I'm sorry, so this is going to be A. This will be A. I apologize on this here, right? It's the third row, second column, so I won't have second column. So my next one will be A2, 3, which is all zeros. I won't have A3, 3, so I'll have A4, 1, A4, 3, and then A4, 4. And if I work my way down, I still get my zeros over here, and my diagonal repeats. And so what happened is I lost the diagonal element here. So this is 0. And if I look at A4, 2, I find the same thing happens here. I enter 4, 2, I get a 0 here, and it continues to zipper down, leaving A1, 1 up at the top there. And so this column becomes all zeros. In fact, we can see that the lower diagonal elements of my cofactor matrix will all be zeros. And so all I need is a value here. I just need one value in here, and I can call this cofactor an upper triangular. So I'm going to look at, right, it doesn't matter form-wise, this will be upper triangular if I have one value in here that isn't 0. It'll be diagonal otherwise. So I'm just going to look at C 1, 3, which is equal to negative 1 to the 4th. And so we don't have the first row. So, so no first row. So the first thing I'm going to talk about, or the third, so I'm going to have A2, 1, A2, 2, and then all zeros. I'm going to have A3, 1, A3, 2. I'm not going to have 3, 3, so it's all zeros from here on out. And then I'm going to have A4, 1, A42, A44, all zeros from here. A51, A52, A54, A55, all zeros from here. So I get a diagonal being made with an extra value popping over. And I'll continue getting this diagonal being made if I work it across. And so this is going to have a determinant. And so C13 is going to have a value. Well, that's all I need to call this upper triangular. These could all be zeros or whatnot, but if we work our way around, these will have values. So, as special cases, some of them will be 0, but not all of them. And so our cofactor matrix is upper triangular. Well, if I take a transpose of an upper triangular matrix, I get a lower triangular matrix. And so our adjoint is lower triangular. And if our adjoint is lower triangular, then our inverse is going to be lower triangular.